Hi students. Okay, today in this videos we learning the topic is Jacobian of the transformation. So what is the definition of Jacobian and what is the problems on the Jacobian? See the first of all definition. So let u and v is the two functions in x and y. Then so the differentiating, that is dou by dou u by dou x dou y, that is equal to differentiation of u and v with respect to x y is called Jacobian of the transformation. And a transformation means u and v is converted to the x and y, the changing of the variables u and v with respect to the variables x and y. It is denoted by j of u comma v by x comma y and is defined as j of u comma v by x comma y is equal to dou of u comma v by dou of x comma y, that is determinant. And dou u by dou x first finding, next dou u by dou y finding, next dou v by dou x and dou v by dou y. All are four values. Now finding the determinant of the all values, that is called Jacobian of the transformation. Data of dou u by dou x, dou u by dou y. Second variable dou v by dou x, dou v by dou y, that is equal to formula AD minus BC kada, dou u by dou x into dou v by dou y minus dou u by dou y into dou v by dou x. This result is called Jacobian of the given variables u and v with respect to x and y. Okay na? This is a two variable function. So similarly we define three variable function u, v, w in the variables x, y, z. So that is equal, it is denoted by and defined as j of u comma v comma w with respect to x, y, z, that is equal dou of u comma v w by x comma y comma z, that is equal determinant of first row is the differentiating of u with respect to x, y, z. Second row is differentiating of v with respect to x, y, z. Third row differentiating of w with respect to x, y, z. Now finding determinant. This value is called Jacobian of the u and v and w. Okay. This is the definition of Jacobian. See the next one. Note. So let the polar coordinates x is equal to r cos theta, y is equal to r sin theta. So that is equal to Jacobian of the polar coordinates, that is the Jacobian of x and y with respect to r comma theta, that is equal to dou of x comma y by dou of r comma theta is equal to formula determinant of dou x by dou r, dou x by dou theta. Second variable y, dou y by dou r, dou y by dou theta, that is equal to here determinant of dou x by dou r means derivative of r 1 and cos theta, dou x by dou theta r into derivative of cos theta minus sin theta. Next dou y by dou r sin theta, next dou y by dou theta is equal to r cos theta. Now finding determinant r into cos square theta plus r into sin square theta, that is equal to r common, cos square theta plus sin square theta is equal to 1. So that is equal Jacobian of the in polar coordinates, Jacobian of xy with respect to r comma theta is equal to direct value r. Okay. And where is using the Jacobian, where using the Jacobian of transformation is useful particularly when we transform the variables conveniently while performing multiple integration. That is, an important application of Jacobian is in connection with the change of variables in multiple integrals. This is one of the application of Jacobian. This is useful in multiple integral. The topic of the change of variable and the xy is converted to the a new variable. Then this is connection with old variable and new variable. This is called Jacobian. Okay na? This is application. See the next one. So properties of Jacobian. So first given the variables u and v kada, and u v is a function of xy. It's Jacobian dou of u comma v by dou of x comma y into, take the reverse Jacobian, and Jacobian of x and y with respect to u comma v, that is equal to, okay, that is take the reverse Jacobian, and u and v is a function of xy. Now changing x comma y is a function of u and y, finding the both Jacobian, then the product of the both Jacobian is equal to 1. This is the first property. Second property is u and v function of r comma s, and r s is a function of xy. Then Jacobian of u and v, Jacobian of u and v with respect to xy and, but here chain rule kada, this is a composite function, so this is also Jacobian is also chain rule. Dou of u comma v by dou of x comma y is equal to, first Jacobian dou of u comma v with respect to r comma s into next Jacobian of r comma s with respect to xy. This is a second property of Jacobian. Next definition, functional dependence or functionally relationship. See that any two functions u and v in x and y are said to be functionally dependent if dou of u comma v by dou of x comma y is equal to 0, and that is Jacobian of u and v with respect to xy is equal to 0, and its result Jacobian is 0 only of u and v with respect to xy, then u and v are called functionally dependent. Otherwise, in case Jacobian is not equal 0, Jacobian is not equal 0, both u and v are called functionally independent. Jacobian 0 is functionally dependence, Jacobian is not equal 0, functionally independent. So that is equal to here. Similarly, Jacobian dou of u comma v by dou of x comma y is equal to 0, then u and v also called functionally relationship, and functionally dependence or functionally relationship. And when the Jacobian is 0, we have to finding the new relation between u and v. The u and v is a functional dependence here. Now if we have to finding a new relation between u and v, say that f of u comma v is equal to 0 when Jacobian must be 0. Similarly, we have to finding the third variables dou of u comma v w by dou of x comma y comma z is equal to 0, then u v w are functionally dependent, otherwise not. This is the properties and another definition. See the problems examples. First one, if u is equal to yz by x, v is equal to zx by y, w is equal to xy by z, then show that dou of u comma v comma w by dou of x comma y comma z is equal to 4. Now finding Jacobian of u v w with respect to x y z, that is equal to, first of all given the u and v w, okay. So now finding first all are differentiation finding, dou u by dou x, dou u by dou y, dou u by dou z, and similarly y z w. First dou u by dou x, dou u by dou x is equal to here 1 by x derivative minus 1 by x square minus yz by x square, dou u by dou x, z by y constant, okay, dou w by dou x, that is x constant, yz constant, y by z. Next to dou u by dou y, dou u by dou y is equal to z by x, dou u by dou y is equal to 1 by y derivative minus 1 by y square minus zx by y square, dou w by dou y, that is x y z. Next with respect to z, so dou u by dou z, y by x, dou v by dou z, x by y, dou w by dou z, minus 1 by z square, minus x by y z square, okay na. This is all differentiation of u v w with respect to x y z. Now finding the determinant of all values, that is a Jacobian. Okay, this is a formula for Jacobian. All are substituting in this one. That is equal determinant of minus yz by x square, z by x, y by x, z by y minus zx by y square, x by y, y by z, x by z minus x by xy by z square. So from the determinant we have to common 1 by x square from first row. From the first row 1 by x square common, from the second row 1 by y square common, from third row 1 by z square common. Remaining here data of minus yz, xz, xy, yz minus zx, xy, yz, zx minus xy. So again from the first column yz common, from the second column zx common, from third column xy common, that is equal. See that all are cancel. Now finding this determinant, minus 1 into 1 minus 1, minus 1 into minus 1 minus 1 plus 1 into 1 plus 1, that is equal to 4. This is a required Jacobian of u, v, w with respect xy. Okay, this is an example on Jacobian. Is it clear, the Jacobian? See the next example. And also u, v, w are functionally independent because Jacobian is not equal 0. Okay. So next, second example, if x is equal to u into 1 plus v, y is equal to v into 1 plus u, then show that dou of x comma y by dou of u comma v is equal to 1 plus u plus v. So that is equal to, given x is equal to u into 1 plus v comma y is equal to v into 1 plus u. So first finding the rate of x with respect to u and with respect to v kada. First dou x by dou u. Dou x by dou u is equal to here rate of u 1 and 1 plus v constant. Dou y by dou u is equal to v. V constant here 1 plus u rate of 1. Next dou x by dou v. Dou x by dou v is 1 plus v and 0 plus 1 into 1 u. Dou y by dou v, that is equal to rate of v1 and 1 plus u. Now finding the Jacobian. Dou of x comma y by dou of u comma v, that is equal to of dou x by dou u, dou x by dou v, dou y by dou u, dou y by dou v, that is equal to simplification after substitution. Data of 1 plus v, u, v, 1 plus u, that is equal to 1 plus v into 1 plus u minus uv, that is equal to 1 plus u plus v plus uv minus uv, that is equal to 1 plus u plus v. This is a Jacobian of x and y with respect to u and v. Okay. See the next example. If x is equal to uv, y is equal to u by v, then prove that j of x comma y by u comma v into j dash of u comma v by x comma y, and a Jacobian of first Jacobian of x comma y with respect to u and v. Second Jacobian the reverse, Jacobian of u and v with respect to xy. The product is equal to 1. This is the first property. See, that is, you will show that the first property. Okay. That is a given x is equal to u v, y is equal to u by v. Dou x by dou u is equal to derivative of u 1 and v. Dou y by dou u is equal to 1 by v. Next one, dou x by dou v is equal to u, dou y by dou v is equal to minus u by v square. So now we have to finding the Jacobian u and v in the functions of x and y from given data. And already given x is x y in the function of u and v kada. Now take the reverse. Now we have to finding u and v in the function of x y. Reverse తీసుకోవాలి. u v లో function of x కు y కి కన్వర్ట్ చేసుకోవాలి. That is equal to x is equal to u v y is equal to u by v. So that implies u is equal to here x by v, u is equal to here y v. So that is equal to x by, and both are, this is a u is equal, this is a u is equal to here, and x by v is equal to y v. That is equal to here v is equal to, right outside x by y is equal v square here, v is equal to root x by root y, and v is a function of x y only. So there is a required v is a function of x, because in the question given only x y is a function of uv but not given uv directly. Though that is the from given the data we have to finding u and v. So v is equal to getting here root x by root y. Next finding u is equal to here yv gada, and v is equal to substituting y is equal y into root x by root y is equal to root xy, and u is equal to root xy. So this is xy, and also we have uv. Now finding the Jacobian. First Jacobian of xy with respect to u and v, and j of x comma y by u comma v, that is equal to determinant of dou x by dou u, dou x by dou v, dou y by dou u, dou y by dou v, that is equal to dou x by dou is equal to v, 1 by v, which is equal to u, which is equal to minus u by v square. Now finding determinant, v cancel 1, minus u by v minus u by v, that is equal to minus u by v. Again the first one. Now similarly Jacobian of u and v with respect to xy, take the reversion. Function u and v with respect to xy Jacobian, that is data of dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y, that is equal to substituting all values. Dou u by dou x means 1 by 2 root x here, and the root y by 1 by 2 root x, dou u by dou y, root x into 1 by 2 root y. Next dou v by dou x, root x and 1 by 2 root xy, dou v by dou y, that is equal to 1 by root y ki derivative minus 1 by 2 into y power 3 by 2 kada. Y power 3 by 2 can write y into root y, after differentiation. Now simplification is root y root x cancel, minus 1 by 4y. Here root x root y and 1 by y, 1 by 2y into 1 by 2y, minus 1 by 4y, that is equal to minus 1 by 2y. This is the first Jacobian, this is the second Jacobian. Product both j of x comma y by u comma v into j dash of u comma v by x comma v, that is equal to product both minus 2 into u by v into minus 2 by y, that is equal to minus 2y. U by y is equal to y gada, by substituting minus 2y into minus 2 by y, that is equal to 1. So this is the first Jacobian, and its reverse Jacobian is equal to 1. So the properties 1 is proved. This is also very important question, the long question. Okay, see the next one. Now, if u is equal to x square minus y square, v is equal to xy, and x is equal to r cos theta, y is equal to r sin theta. So this is a chain rule, and u v is function of xy, xy is a function of r and theta. Now finding Jacobian of u and v with respect to r comma theta by using chain rule. There is a given dou of u comma v by dou of r comma theta is equal to u v is a function of xy gada, Jacobian of dou of u comma v by dou of x comma y, and xy ki Jacobian dou of x comma y by dou of r comma theta. So that is equal to determinant of dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y into dou x by dou r, dou x by dou theta, dou y by dou r, dou y by dou theta, that is equal to finding dou u by dou x 2x, dou u by dou y minus 2y, dou v by dou x 2y, dou v by dou y is equal to x, dou x by dou r cos theta, dou x by dou theta minus r sin theta, dou y by dou r sin theta, dou y by dou theta r cos theta, that is equal to 4x square plus y square. This is equal to r cos square theta plus r sin square theta. 4 into x square plus y square into r common cos square theta plus sin square theta. That is equal to x square plus y square is equal to, you know that, r square. 4r square into r, 4r cube. This is the required result. See the next one. Show that the functions u xy plus yz plus zx, v x square plus y square plus z square, w x plus y plus z are functionally related, that is functionally dependent. Find the relation between them. Functionally related means the Jacobian of the given function u, v, w with respect to x, y, z must be equal to 0. That is called functionally dependence. That is the same finding here. U, v, w is given. Now we have to show that the Jacobian is 0. So Jacobian dou of u comma v w by dou of x comma y comma z is equal to, this is a formula. So ux means dou u by dou x. Dou u by dou x means y plus z. Dou uy is equal to x plus z. Uz is equal to y plus x. Next to vx, vy, vz. That is equal to 2x, 2y, 2z. Next to wx, wy, wz. That is equal to the rate of x, y, z. 1, 1, 1. Now simplification is find the determinant. Y plus z into 2y minus 2z minus x plus z into 2x minus 2z plus y plus x 2x minus 2y. All are multiplication and adding and substituting. All are zeros and all are cancel. This is total value cancel and all terms are cancelled, that is equal to 0. So its Jacobian is 0. Therefore the given functions u, v, w are functionally dependent. So now we have to finding the relation between u, v, w. That is equal to here. Now w square is equal, w is equal to x plus y plus z whole square finding. That is equal to x square plus y square plus z square plus 2xy plus 2yz plus 2zx. But x square plus y square plus z square is equal to v. The 2 common xy plus yz plus zx is equal to u. Therefore new relation is u between u, v, w. W square is equal to v plus 2u is functional relationship between u, v and w. This is also model important question. Okay, thank you. In this video we learned the topic is Jacobian of the transformation and some problems on Jacobian. For more videos please do subscribe my channel, like and share it. Thank you.